Hi everybody. This is Dr. Bitla Venu, working in Government Polytechnic Parkal as a senior lecturer. Uh, Today, I would like to tell regarding the introduction to CAD CAM. So, this is the subcontent of the first chapter in C18 curriculum CAD CAM subject. So, probably it can take around 40 minutes. So the objective of this slideshow is to see the overview of CAD/CAM. Then we will see the CAD/CAM cycle with information flow. So it is a typical CAD/CAM cycle with information flow. I mean, how information is flowing from one place to another place, we will also see in that figure. Then we will see what exactly the CAD introduction. We will see what is the meaning of CAD. We also try to define what exactly the CAD is. Then we will see the benefits of CAD after defining uh, different benefits by using CAD. Then what exactly the steps required to implement CAD. So these are actually the objective of this slideshow. So when it comes to the overview of CAD CAM, so the objective of any of the manufacturing industry, any of the firm, is to produce the products with the lowest possible cost. Uh, you take any industry or any firm, so their ultimate aim is to reduce the cost of the product. Uh, that is the ultimate aim. The current trend of the manufacturing is, I mean, day by day, the technology is improving. So with respect to the technology, the cost of the product is also reduces automatically if you don't adapt the technology. In the current trend of manufacturing, so we cannot stay in the global market. So that is the crucial point we need to identify, we need to recognize whenever we want to stay in the market, in the global market, because the whole globe is, in the globalization policies, you should be able to produce the products with the lowest possible cost. Then only we can stay uh, in the market. So we need to adapt the technology. So as early as possible to produce the cost with the least possible price. So the technology is also improving. So with respect to the technology, the speed, accuracy, and the reusability of the data is also increases, because technology means nowadays the computing machines are coming. Computing machines means the computers. The usage of computers is also increased day by day, everywhere, any office, any industry, any mission. So everywhere you will find the computing missions. So those missions are really helps us to increase the speed, accuracy, and the reusability of the data. So without this, so we need to put more effort to increase the accuracy, to increase the speed. So as the technology is improving, we need to adapt that technology. So otherwise we cannot stay in the market. So this is what exactly we need to adapt the technology. So then design and manufacturing terms, our subject is computer aided design and computer aided manufacturing. So what exactly is the design and what exactly the manufacturing? So we will try to define, we'll try to see the steps later in the coming slides. So the design and manufacturing terms basically are, because with the uses of the design and manufacturing, the usage of the computers are increased in the design side and the manufacturing side. so that the design and manufacturing are evolved as the computer-aided design and computer-aided manufacturing. So in other words, we can say that the use of the computers in design and as well as manufacturing is increased, so that the design term and the manufacturing term is evolved as computer-aided design. In short form, we can call it as CAD, and the manufacturing is termed as computer-aided manufacturing. So the aid of the computers is increased in design and manufacturing side, so that these terms, design and manufacturing, are evolved as computer-aided design and computer-aided manufacturing. So CAD-CAM is mainly concerned with the application of the computers, as I said just now. So you see the drawing phases. If you take the design phase, if you consider the design phase, so design involves a number of steps like drafting. So initially, drafting, basic step is drafting. Then we need to plot, we need to simulate, we need to produce the 3D drawing from the 2D drawing. Then we need to analyze that. So based on the design, we need to analyze the feasibility of the design. So if the feasibility, I mean, if you find, if you satisfy the feasibility of the product, then you can proceed further for the manufacturing. So these two are the two important steps in design process. Basically, CAD and CAM is going to, I mean, incorporate, I mean, used from the design phase to the production phase, and the quality control to the warehouse. So from the starting point, from the drawing to the, after producing them, after producing the product, the products will be sent to the warehouse. The CAD and CAM activities are involved between drawing phase to the warehouse phase. So all those activities, all these activities are performed during design and manufacturing phase. We will try to see what exactly the design steps, I mean, what are the design steps involved, what are the steps involved in design, and what are the steps involved in manufacturing. We will see in detail in coming chapters. Basically, CAD and CAM is mainly concerned with the application of computers from the drawing phase to the production, and also from the quality control to the warehouse. When you come to the typical CAD-CAM cycle, so if you open any CAD-CAM textbook, or if you try to read any content related to the design, related to the manufacturing, so there must be some information flow between CAD and CAM. We will try to see what exactly the information is flowing from the starting phase to the production stage in typical CAD-CAM cycle. So with this, we will try to see the information flow of CAD and CAM from the conceptual design to the machining, CNC machining. In this cycle, basically this cycle starts from the conceptual design information, I mean, conceptual design. This cycle starts with the conceptual design. Conceptual design means you are going to identify a problem in this stage. Based on this problem, based on this concept, you will gather some information. That information is termed as conceptual design information. Example, you take one shaft, you want to design one shaft. The objective of or the motto of that shaft is to transmit 5 kilowatts power from one end, from driver shaft to the driven shaft. So that is your requirement. Your requirement is to transmit the power from one location to the another location. Your objective is to design one shaft. That is exactly your concept. You have to design how much diameter shaft is required to transmit 5 kilowatts power. That is your concept. Then you proceed further. Initially, I have taken a shaft. It may not be a shaft. It may be a coupling. It may be any component, mechanical component. The moment when you have a concept in your hand, conceptual design data in your hand, based on that conceptual design, we are going to create a model using any of the solid modeling software like Pro-E, CATIA, Unigraphics, SolidWorks, SolidEdge. You have number of solid modeling softwares which are very much flexible to create complicated models. So these models, what I mean to say is these models are very much flexible to create the advanced surfaces like B-spline surfaces, toroidal surfaces. These are very much flexible. So these softwares are these commercially available softwares. I mean, these softwares are available in the market. So we can use any of the software. Using any of the solid modeling software, we are going to create a solid model. After creating a solid model, we are going to convert that solid model into a neutral format file. The neutral format file is going to carry all the boundary representation data of the solid model, which includes the lines data, vertex data, surface data, planes data, all the information. This neutral format file is going to carry all the information related to the solid model. So this solid model is converted as a neutral format file. There are different types of neutral format files. The advanced file nowadays used is STEP, Standard for Exchange of Product Model Data. That is an ISO approved file. Can be IGS file, Initial Graphic Exchange Specification file. That is also one type of file. Then STL file, stereolithography file, which is used in the 3D printing. Frequently, STL file is used in the 3D printing. So after converting the solid model into the neutral format file, that neutral format file, from the neutral format file, the features will be identified. Manufacturing features. Manufacturing features are nothing but the region where the focus we have to manufacture. Example, you take a hole is a feature, blind step is a feature, then throw hole is a feature. All these feature is a region where we have significance towards manufacturing. So after identifying all those features, we need to move for the process plan. Process planning is the stage where the information required to process the machining, like if you want to produce a hole, we require how much speed the drill bit needs to be rotated. Based on the material, we need to select the speed. Then feed, speed, type of tool, all these information, type of machine, all these information will be selected during the process planning stage. It is also the computer aided process planning nowadays, but in the olden days, in the olden era, we have experts, process planning experts. They will decide based on the material, based on the experience, how much speed, how much feed, how much depth of cut, on which machine we need to perform the machining. Process planning experts will decide that. But now we have the computer aided process planning. We have a database there, means we have a computer there. All the data will be fed into that computer. From the computer, we will select the speed, feed, and depth of cut and the type of machine. After computer aided process planning, then the process planning information, based on the process planning information or from the process planning information, G code and M codes, G code and M coding, or NC coding, or CNC coding, computer numerically controlled coding. Using that G code and M codes, we will program. G code, M codes are the instructions where, these instructions can be understood by any of the CNC machine. So these are all the sequence of the steps. The coding will be in the form of blocks or the statements using alphabets, also using numbers. Using numbers and alphabets, we will instruct the machine to perform the operations. After coding, the program will be fed into the CNC machine to perform the operations. This is exactly the typical CAD/CAM cycle from the conceptual design to the NC machining. Basically, we have a concept. Based on that concept, we will create a model using any of the solid modeling software which are commercially available in the market. This solid model is then converted as a neutral format file. Neutral format files are maybe different types. So these neutral format files may also, based on the, these neutral format files may also based on the application. Suppose if you want to integrate, or if you want to produce, if you want to produce a product on the 3D printing machine, so the type of format is different. That is STL file. So after converting the solid model into the neutral format file, that neutral format file will be sent to the process planning stage, where the parameters required to machine will be selected, like speed, feed, and depth of cut, and also the type of machine. The parameters required to machine will be selected in this stage. Process parameters, basically process parameters, computer aided process planning. All these will be, all the parameters will be selected in this stage. Then that process planning information will be used to program, which is normally G code and M code, CNC programming, that is also termed as a CNC programming. That CNC program is again fed into the CNC machine to machine the object. This is exactly the typical CAD/CAM cycle and its information flow in any of the CAD/CAM implementing industry. When you move forward, uh, when you come to the introduction to the CAD, the previous slide we have seen the information of the CAD/CAM flow. Right? In the typical CAD/CAM cycle, how information is flowing, we have seen in that slide. Computer aided design is a technology, basically technology. So using that technology, the I mean everything will be documented. The products are designed, analyzed using a computer. Most of the people will assume that CAD means computer aided drafting, but it is not drafting. It involves the analysis also along with the drafting. Most of the people will think that the CAD means computer aided drafting, AutoCAD like that, but it is not like that. It also involves the analysis process. This is the major step in design process. Computer aided design is a technology that designs a product and documents the design process. This computer aided design, CAD, is going to use and assist the computers are for the architects and also for the other design professionals and every of the activities. As I said just now, design also includes the analysis part. The computers are really helpful in analyzing the parts. Example, if you take a shaft, as I said just now, a shaft is used to transmit the power, 5 kilowatts power in between the driver and driven, which are at a certain distance. While transmitting the power, so stresses will develop. If you exceed the power of transmission, the shaft may fail. At which point it is going to fail? So if you use the softwares, CAD softwares, so number of CAD softwares are available. Abacus is one software, analysis software. ANSYS is one analysis software, commercially available in the market. Using those softwares, the models are analyzed, like maximum stress induced, minimum stress induced. Even you can simulate using this software. Simulation means if you exceed the load on the shaft, if you exceed the power on the power transmitted by the shaft is going to fail. Even you can see the animation where exactly the shaft is going to fail. In that manner, computers are extremely useful in design side. Really, the computers are going to assist the designers to increase the speed and accuracy and also the reusability of the existing data. Then let me move forward. Then what exactly we will see the reasons. What are the reasons for implementing CAD? The first is to increase the productivity of the designer. Productivity of the designer means, assume that a designer took 1 month time to design a coupling. Of course, he may not take that much time. If a designer takes 1 week time to design one coupling, if the designer uses the CAD software, he can design 2 to 3 components in 1 week. In that way, the productivity of the designer definitely increases. Also, the quality of the design also increases. If you see, the designing includes number of calculations. If the calculations are performed manually, it may lead to the error. If all the calculations are performed by using a computer, definitely it may lead to less errors. In that way, we can increase the quality of the design. Remember that it is the quality of the design, it is not the quality of the product. We are in the design stage. The productivity of the designer increases means the designer is going to design number of products within a less time. Then the quality of the design increases means the designed calculations may not have any errors. In that aspect, the quality of the design increases. When you implement CAD, it also improves the communication through the documentation. If you design using a computer, really you can take any number of prints. So the documentation is very easy when you use anything using a computer. This is what the reason for implementing the CAD. When you come to the benefits of the CAD, it decreases the error percentage. Definitely, we are using a computer. You have a program. Once the program is in your hand, okay, when you run that program any number of times, definitely the error will be less. When you perform the calculations manually, definitely that may prone to the errors. When you implement CAD, also decreases the effort. If you want to perform the complicated design, if you want to design a complicated component, really it is having number of calculations should be performed in a number of iterations. This is really a typical task to perform the iterations. If those calculations are performed using or assisted by a computer, so definitely the effort reduces. It saves time, definitely. It is a computer, definitely it saves time. Within a short span of time, it gives us the result so that we can save the time. It also easy to edit. To design the new component, suppose if you want to modify the existing one, editing is very easy, right? Suppose if you perform the calculations manually, if you find any error, it is very difficult to carry out the calculations right from the scratch. If all the calculations are performed on the computer, you can go to that a certain point, you can go to the point where you have error, you can make the alteration, then you can execute the program to get the result. What I mean to say is it is easy to edit. You have a program, you can edit that program as per our requirement. This is really flexible to design the new components. By altering the existing design, we can design or we can refine the existing design to model or to create a new model. Reuse of code, as I said just now, you have an existing code with you, you have an existing model with you, you can modify that as per your requirement to get the new product. It is very difficult to develop the code right from the scratch. If you have a computer, definitely that code can be altered as per your requirement. The reusability is very high when we use the computer. Improved accuracy, as I said just now, accuracy ultimately increases because we are using a computing machine. And finally, you have data, you have program with you, right? Those programs can be shared easily to other people. This is very, even you can send the program in the form of storage devices or in the form of internet, you can transfer the data. It is very easy to share. Otherwise, if the programs or if the data is in the form of document, so it is difficult to transfer, or if it is difficult to share the data. We need to remember that easy to share, accuracy increases, reusability is more, easy to edit, it saves the time, decreases the effort, decreases the error percentage. Those are all the advantages when we use the CAD. When it comes to the stages of the CAD, basically we have 6 stages in CAD. One is, the first stage is identifying problem and recognizing the need. Identifying problem means recognizing the need. I combine together. As I took one example just now, my requirement is to transfer or connect the driver shaft and driven shaft to transmit the power from one location to another location. That is my need. The problem is that how much diameter shaft is needed to transmit the power from one location to another location is my problem. The need is transmitting power from one location to another location. The problem is how much diameter shaft is required to transmit power from one location to another location is the identifying problem. Then how do you perform this step? During this step, so these are all the information that you require that you can see on this screen. Basically, you have some historical information. That means already you have one shaft in between driver and driven shaft, as I said just now. Previously, you may use one shaft of one so and so diameter shaft, and the shaft material, and that shaft is used to transmit so and so power. That is the history of the problem. You gather the information for the problem to define the problem. Based on the need, you defined the problem. The problem requires some information which can be historical information. Already you have some information. Gather that information. That information is extremely useful while designing a component. Then specify the requirement, as I said just now, recognizing the need, which comes under this. We should also assess the market forces. Market forces means after calculating the design elements, if that same component is available in the market with the lowest price, it is better to purchase that. Market forces means we should analyze the market where this product is available. If this is available with the lowest possible cost in the market, better to purchase instead of manufacturing. If you want to manufacture the components in a very large size or in mass production, so the cost of the product reduces. Suppose if you require only one product, if you require only one shaft, instead of designing, instead of analyzing, instead of manufacturing that component on the mission, is waste of time. So this is all the market analysis, market strategy. Based on your requirement, you should assess whether you need to purchase that component or whether you need to go for the manufacturing. This is what the market forces. Then you should find the general solution, crooked solution from the basic rules. Try to find out the basic solution for the component from the basic principles. These are all the required inputs for the stage one. The stage one is problem identification and recognition of the need. The second stage is problem definition. The problem definition requires these inputs. The first input is preliminary design. Preliminary design means from the basic principle, we can get some solution basic principle, basic rules. You can design. You have a problem, you're already defined a problem in the previous step, that is your requirement. Then from the basic principle, you can design some extent, may not be analysis side, some extent you can design from the basic principles. We can also create the preliminary sketches, what exactly the need, rough sketches on the paper. We can sketch those. Then if it is a complicated component, we must need to produce that. In that case, brainstorming session should be performed with the experts. They will discuss what is the feasibility of the component to manufacture. So during these sessions, the experts will decide the manufacturing strategy during this stage. So this stage also requires this information. Finally, in this stage, we need to evaluate the design. We need to move further for the design process. The first step and second step are very, very important in the CAD stages. Then the third stage is geometric modeling. Geometric modeling, in the first slide, as I said just now, in the typical CAD CAM cycle, we have solid modeling. We are created solid modeling software. We are created solid models using solid modeling softwares, which are commercially available in the market, like Solid Edge, SolidWorks, Unigraphics. We can create a model using those softwares. After creating, we should be able to visualize the component. During this stage, we are going to model, we are going to visualize the component, how that looks like after manufacturing. Of course, it may not be optimized. It is a rough stage. Okay. After modeling, you can visualize the component in any of the solid modeling software. Then we will go for the analysis. I said just now, we have number of analysis softwares are available in the market, like ANSYS and Abacus. Using those softwares, we will analyze the component, we will analyze the model, solid model. During this stage, I said just now, we are mechanical students. Whenever you want to design any component, basically you are going to calculate the maximum stress, minimum stress, where it is going to fail, at which it is going to fail, where you have a smaller cross section area. You have, if you consider a shaft, if a shaft is subjected to under tensile load, definitely that is going to fail where you have minimum cross section. Like that you can analyze the component in the analysis softwares using any of the commercially available softwares in the market. That stage, that analysis will be performed during this geometric modeling stage. Comparative evaluation. Suppose if you have existing component, we can compare this analysis, this model with the existing model to get the comparison, whether it is feasible to manufacture this component with respect to the existing design. We need to compare the existing design with the design of the component that we are going to manufacture. Then we have the fourth stage, that is engineering analysis. I said just now, here the preliminary analysis is different. It can be a simple stress, it can be a maximum stress, minimum stress, like that. But whereas when it comes to the critical analysis, it can be a static analysis. Static, when the body is at rest, when the component is subjected to the load, that is called the static analysis. Then the kinematic analysis. Okay. A machine consists number of links. So each link is having the motion related to the another link. So that analysis must be performed during this stage. Dynamic analysis, there are some components which are in motion. That analysis also needs to be performed. Then heat flow analysis, there are some components, there are some missions, so which are exposed to the very high heat. So that analysis also needs to be performed. Then design for manufacture, I mean manufacturing assembly, DFMA. Basically, this is DFMA, design for manufacturing and assembly. When you assemble a component, how it looks like that, whether the relative motion between the links are feasible or not, all these analysis will be performed during this stage. One is static analysis, kinematic analysis, kinetic analysis, dynamic analysis, heat flow analysis, DFMA. All these are very, very important steps in almost all the CAD stages. This is the very, very important stage. Then the fifth stage is prototype development. We are analyzed the problem. We are created a geometric model. We are analyzed critical analysis, static analysis, dynamic analysis, heat flow analysis, DFMA. After analysis of the component, we need to create a prototype of that. Prototype means a small model, or which is a replica of the original model. The size of that model is less than the original one. That replica is created for the testing purpose. We will apply the load. We will apply the different loads on that. Based on that load, we will analyze whether the design is feasible or not. A small prototype is developed. That prototype is tested and evaluated. So after preparing the prototype, after analysis, okay, we need to define the requirement. Okay, or this stage can also be termed as the feasibility, or you can also tell this as a design refinement. Means if you find any difficulties or if you find any errors during that testing stage, we can refine the design. Means by altering some parameters, maybe you can increase the diameter, maybe you can reduce the diameter to optimize the design. That is called refinement. The design should be refined after the prototype testing. Then after refining the design, means after modifying the design, after testing and evaluation, working drawing should be created. The clear drawings are created again in using any of the 3D modeling softwares. The original, this is actually the fair drawing that needs to be sent to the production. This is the fifth stage. This is also very, very important stage in CAD. The last and final stage is manufacturing process development. During this stage, process planning will be performed. As I said just now, process planning will tell us what type of machine, what tool we need to use, what will be the speed of the tool, speed, feed, depth of cut, and all those machining parameters are selected during this stage based on the material type, based on the finish requirement, surface roughness required. Based on that, the process parameters are selected. In this stage, after process planning, manufacturing information will be generated. Manufacturing information means which includes the generation of NC code using the G code and M codes. Numerical control programming will be carried out in any of the computer. This G code and M code program, in turn it can also be called as NC program, will be simulated. That program will be fed into the NC machine for the simulation. Before going to the actual production, the product will be simulated on the machine. Whether the machining is going to perform in an accurate way or not, that will be carried on the simulation stage. Then the final one is the time and motion study, how much time the machine is taking and how the operators are doing work on the CNC machine. Time study and motion study will be carried out during this stage. This stage is also very, very important in the CAD stages. This is the sixth stage. This is a very typical stage in all the six stages, typical as well as important stage. With this, I close the session. Thank you one and all for this session. Thank you. Stop.
Recording stop. Stop. Pause recording. Stop recording.